Seeing PPT's starting slide. Yeah, is it visible to you?
Yes, yes. You are audible to you.
Yes, thank you so much. So today I am here to present my session about PP. So the topic name is next generation vehicle communication. So already sir introduced myself. So my name is Dr. Pranat Ravi. So I did my PhD from IIT Kanpur. I could like to clear as assistant professor department of PC. So I joined 3 years back. So and I have total experience in more than 10 years in teaching. So today I'm here to present. So the topic name is related to vehicle arachnids, planets. So what is the problem in planets? So nowadays in vehicle means in road highways, so we are seeing several accidents and several traffic jams. Like so, based on that, how we can control the highways networks and how to avoid the accidents and how to improve the congestion. So based on that, there are several problems in highways. So those problems, so we can work by using
Dr.
the
Ravi,
technology in this.
I'm
Yeah.
interrupting you. Somebody is saying that your voice is a little bit not clear actually.
Can you hear me?
Yes, I can hear you.
Is it okay for you?
Is there clear sound, Dr. Utoshi Sarkar? Dr. The sound is clear.
The sound is echoing much.
Just give me 3 seconds. Hello. Yeah, can you hear me?
Yes.
Because of that fan sound. So I am in my cabin only. So now I switched off my fan. So can you hear me now?
Yes, yes, I
Yes,
can
sir.
hear.
Yes, sir.
Yeah, thank you. So the problem in that highways, so there is several accidents and there is several traffic jams. So how we can avoid by using the technology in this car? Vanish. So vanish is nothing but a vehicle arachnids. So it is subtopic of mobile arachnids. So we can use this technology in intelligent transportation system. So based on that, we can avoid for link failures and we can actually vehicle arachnids is a dynamic network topology. So there are several problems. So those challenges we can avoid by using the vehicle arachnids. So in that vehicle arachnids, we can use our 5G technology. There is very green technology, 6G, and we can call it as enabling technologies. So there are several enabling technologies nowadays we can apply to integrate the performance, so system performance, and we can improve the different quality of services. So which means that ultra low latency communication, reliable communication, and for example, we can call it as see how we can avoid based on these techniques. So we can go through one by one topic. So uh, first of all, so what is mean by vehicle arithmetics? So generally nowadays you can see that figure A and figure B. So we can call it as vehicle to vehicle communications, which means that either two vehicles they can moving time they can communicate their information exchange between the one vehicle to other vehicle within the transmission range. So and we can call it as vehicle to vehicle communication. So vehicle to infrastructure communication means so we can call it as roadside units are act as a base station, and this base station to vehicles, moving vehicles, they can transmit the data. So the data means either packets related information or traffic related information or internet related information, or they can exchange between the vehicle to infrastructure. So like that, we can call it as the name is nothing but vehicle to infrastructure communication. So vehicle are networks. So we can call there is two types. So one is vehicle to vehicle communication. Second one is vehicle to infrastructure communications. So single, what do you mean by single hop communication? So which means that one node to another node. So we can call direct link between the one node to another node. Node is nothing but here vehicle. So vehicle to vehicle means a single hop. So vehicle to multiple nodes, they can transmit the data at particular instant of time or particular region, a particular transmission range, they can transmit the data. So in that case, we can call it as multi-hop communication. Sorry, clear? So single hop means only one vehicle to vehicle communication. Multi means one vehicle to multiple nodes, multiple vehicles. They can transmit the information exchange between the one vehicle to another vehicle. So we can call the name is multi-hop communication. So next one. So there is a several problem, for example, in vehicle networks. So advanced domain we can integrate in that vehicle networks. The name of topic is nothing but software defined networks. So by using this software defined networks, so we can control network dynamically, and whatever the link failures are particular instant of time. This network is entirely random networks. So we can call it as dynamic networks. So which in that case, vehicle to vehicle communication or vehicle to infrastructure communication, if in between there is a link failures or there is a congestion happen. So dynamically and programmable way also we can control by using centralized control. We can call it as. See, this figure says that. So for example, the upper part. So this is a control plane, and in between the servers to base station. So this part is, we can call it as control plane. So control plane is nothing but centralized control by the networks. So with the efficient manner. And for example, this is my data plane. So data plane is nothing but forwarding data from one vehicle to the another vehicle, or in between the vehicle to vehicle communication or vehicle to infrastructure communication. So what are the problems? So how we can those challenges, for example, forwarding long distance or particular network, how we can control a centralized way, and how we can give the programmability and how reliability we can maintain from one location to another location for transmission of data. So it is possible. The name of domain is nothing but software defined vehicle networks. So software defined vehicle networks here we can call control plane and data plane and network function virtualization and service provisioning. So which means that by using these software defined vehicle networks, so we can give more services to the users, which means the data related or bandwidth related or internet related. So we can provide efficient manner by using this emerging technology name is nothing but software defined vehicle networks. And the next one, advanced technology name, so we can call it as software defined heterogeneous vehicle networks. So software defined heterogeneous vehicle networks, which means that so we can integrate different advanced technologies, for example, 5G, 6G, and IEEE standards, and those kind of enabling technologies. So we can integrate, and our main goal is we want to maintain the efficient link between the either vehicle to vehicle or as a roadside unit to vehicles. So in that case, our main goal is we have to follow the means we have to improve the link, and we have to give the efficient data to the users. So those kind of challenges we can overcome by using the software defined heterogeneous vehicle networks. So here the main word is we are transmitting the packets. So packet means we know data that in computer networks we can call it as packets. So we are transmitting the data transmitter to receiver. So the data we have to maintain the reliable data, and we can call it as efficient data. So that data how we can control by using the heterogeneous communications. So heterogeneous means we can use different new technologies. We can enable those technologies and we can improve the system performance efficiently by using the software defined methods. And what are the key challenges? For example, if you are going to start this research related to this topic, so what are the major challenges at present scenario in vehicular networks? If we are going to do research, so what are the problems? What are the how we can overcome this problem? What are the softwares we can use for based on this technology? So, for example, connectivity. So connectivity is always major issue. Suppose the vehicles are moving randomly, so based on speed, location, and how we can give the connection between the node means vehicle to vehicle or vehicle to infrastructure. Either we can go for single hop communication, multi hop communication. So in that case, now I told you, so of course we can use for software different vehicle networks software different heterogeneous vehicle networks. Nowadays, advanced technology also came. So those technologies nothing but digital twin. And we can use 6G technologies and several learning models, for example, stochastic learning and machine learning and deep learning and federated learning. Those learning models we can provide the better connectivity from the vehicle to vehicle or vehicle to infrastructure communications. And mobility also one of the major issues. Mobility means, for example, topology is always changes from one node to another node. There is a problem in that speed. So one location to another location. So how we can control that kind of mobility prediction based on we can use different protocols, so routing protocols, and we can use for example the Gauss Markov models in stochastic models. So we can realistic way we can control the network performance also based on the different stochastic model applications. And congestion nowadays, congestion also very challenging topic in that vehicle networks. So we can apply same concept with the routing protocols. Suppose there are several protocol routing protocol we can discuss in time. So AOD, DSR, DSDB, and normally in case of advanced protocol also there is zero. Based on our model, based on our network topology related, we can integrate new routing protocol and you can find the link, the shortest path routing, shortest link between the node to node or vehicle to infrastructure. Right. So, and the data traffic forwarding also one major challenges in vehicle networks. So, which means the data traffic means, for example, we are transmitting the data based on single hop or multi hop. So, what is the link failure? Then how we can provide? So, immediately we can search in particular network what is the path between the nodes, how we can select. So, and for example, here we can follow the queue. Queue means we can wait at a particular time and we can choose another path also. Yes. So these all are we can call it as major challenges, and the routing also we can provide a unicast protocol or broadcast. Uni means single, broadcast means multiple. We can transmit multicast means multiple devices. We can transmit the data and within the shortest path route. So, and cooperative communication also one of the major challenges between vehicle to vehicle communication or vehicle to infrastructure communication, or we can call V2S also, vehicle to anything, and Internet of Vehicles. So, like that, how the cooperation we can provide from users to users. So, like that, this is also one of the major challenge. And data decimation, which means that we are forwarding data between the vehicles to vehicle or vehicle to infrastructure. So how we can provide data destination between the users, and what are the quality of services. So how we can improve those quality of services, for example, throughput, delay, or any kind of network related qualities. So how we can provide these services to user, which means that in that case, you can apply stochastic models and Markov models and different routing protocols. Yeah. Yes. Yeah. Is there any doubt?
कठिन लगवाए कि आए थे
Please unmute.
Okay, Manoj, please continue.
Yes. So, at present scenario, the major challenges is quality of services. So, how to improve the users related, utilization related, and resource allocations. For example, we are going to give a particular resource allocation to users. So, how we can improve mathematical way, protocol way, technology point of view. So based on that scenario, we can improve the QoS. QoS is nothing but quality of services. So, for example, if you are going to start for research by modeling and analysis of vehicular networks, so what are the major at present scenario? You can go refer the stochastic process, and you can use queuing theory techniques, queuing theory models to integrate your models, means which we can design your network efficient manner, and Markov chain. So like that we can use for mathematically, and we can analyze the system performance at a better manner also. So these all are at present modeling and analysis for vehicle networks. So you can well and good means stochastic process. There are several random variables, and we can predict the mobility model also, and based on that we can predict the traffic prediction. So stochastic means the particular means collection of variables in the index of time. So in a particular time of instant. So it is nothing but random variables or random process. So in that our network is dynamic network, means anytime anything will can join, they can utilize the data, or then what problem will occur means we can overcome by using the stochastic process modeling. And queuing theory also at present scenario in modeling and analysis point of view. So we can apply traffic modeling, and we can apply for network management. So, and we can use for performance evaluation, and we can use the service provisioning, and we can ensure the whatever the traffic related flows and congestion control by using the queuing theory models. There are several models, so I can refer the next slide also. And Markov chain. Markov chain means suppose what is happening in future. Future next means in case of traffic congestion. So we can predict in that case by using the Markov chain model concepts. So, what is the motivation in that case means? So, our topology is dynamic topology, creates some mobility related things, and VANET topology is always dynamic model. So, how to control the link failure, and how to avoid the suppose we are using suppose wireless networks. So, wireless links. So, this links is very short. So in that case, we can adopt the different technologies, and those technologies we can improve the this dynamic change of data from one location to another location. So here what we are main goal is we are sharing the data between the vehicles or between the vehicle to infrastructure. So at a particular time of instant, so we can improve based on those software-defined networks or software-defined heterogeneous network. So those technologies we can improve the data sharing efficient manner, and we can reduce the congestion, and we can improve the connectivity between the vehicles to vehicle or between the vehicle to infrastructure. So mobility, I told you, mobility is one of the major problem. So how we can, based on the different routing protocol, we can improve the mobility related issues. And there is a several, we propose one protocol here. So multi-hop cooperative data destination protocol. It provide accurate data between the shortest path, between shortest path, which means that vehicle to vehicle, or if you are considered single hop, so what is the shortest path to go? If you consider multi hop, so what is the shortest path? So based on that, we can use multi-hop cooperative data destination protocol will provide efficient data between the vehicles or between the infrastructure communications. And suppose our vehicular networks, so traditional vehicle networks, why we are going for software defined networks, which means that so we can easily control the network base by using the software defined networks, control plane, data plane. So based on those plane, we can usually integrate the topology, and programmability also possible by using the software defined networks, and dynamically we can control the network based on in particular time of instant, and we can predict the mobility also by using the software defined and software defined networks. And based on this two technology, we can improve the network performance, which means reliability of a link between the node to node. And I told you, ultra reliable latency also we can minimize, means we can improve based on this software defined networks. And better we can provide the network utility for the users point of. And those challenges we can overcome by using the software defined and software defined networks. And the major objectives, whatever we discussed, we are starting. So those are objectives. Based on objective, we can discuss one by one. So the first objective, how to avoid congestion or collisions in between the vehicles to vehicle or vehicle to infrastructure communication, which means that. So here the basic protocols, for example, AODV, ad hoc on demand, and vehicular ad hoc on demand, and open shortest path routing. So we can see those protocols. So we can give that means collision warning between the vehicle to vehicle and vehicle to infrastructure communication. So we can reduce the collision in the highway, particular highway. So these protocols are, we propose vehicular AODV, and based on that, we compare the what is that condition, how to avoid condition. So this system means this system network. So for example, the name is nothing but inter-vehicle communication, which means that vehicle to vehicle communication. So cluster head. So this based on this cluster head, we can avoid the vehicle to vehicle congestion. So cluster head always provide the warning messages to in between their location of that vehicles. So we related to traffic related or any kind of infotainment related. So cluster head will give that information between the near location of the vehicles in between. So we can avoid the congestion, or we can avoid the any means accident related information. So for example, if figure B, you can see that so running between two vehicles. So for example, same opposite direction. So which means we can, by using cluster head, immediately pass the information between car A or car B. So they can alert the warning alert, and they can it means the safety related safety issues, means the safety related before the cluster head will give the information to nearby vehicle, and they can alert the warning related information. So, so for example, you can see that by using any network simulators, open software simulators. So there are several open software simulators and commercial softwares also. In case of if you are well and good in Java or CPP or Python, so in that case you can use network simulator 2 or network simulator 3 or OMNet also. And in data sets point of view, you can integrate OMNet. So this parameters is related to I use OMNet and we integrate Sumo software. So based on that Sumo software is nothing but which means the data sets based on that we can integrate Sumo and OMNet. And based on that, we use these simulation parameters. So you can fix that simulation time and you can use for your own protocols and based on that your own protocol you can adopt the that OMNet and you can integrate with this OMNet software to Sumo software. So and in that case you can choose your wireless channel which kind of transmission range and what are the number of nodes required minimum, maximum, and you can select the packet size, bandwidth, everything. So based on whatever you are mentioned in that program, so you can design that and you can integrate into the Sumo software. And before that, you can fix your whatever your data rates, how much data rate. So IEEE 802.11p, this is one standard protocol. Based on this protocol, we can go for the frequency range 5.9 gigahertz, and the data rate maximum rate is 27 megabits per second. So based on that data rates, you can transmit that transmission happen from vehicle to vehicle and vehicle to infrastructure. So based on that protocol, so we perform the results. So and we perform the delay and based on the data rates. So whatever the proposed vehicle or vehicle AODV, so it will gives very low delay compared to the existing protocol. So you can see that figure left side. So AO means AODV compared to the YSPF is high means very high latency once you are going to increase your data rates also. So our proposed protocol will give very less delay compared to the existing protocol. And the right side also you can observe if the number of vehicles is going to increase means so which one is less delay means our proposed protocol. This is based on our OMNet software and Sumo software. So we perform this result analysis. And what is meant by suppose we focus for throughput also. Throughput is nothing but whatever the successful of our packets we are delivering from one node to the another node. So from transmitter to receiver, from source to destination. So what is the throughput? So if we are going to measure throughput bits per second, so same here we are means changing the data rates and based on that what is the throughput scenario based on these two existing and our proposed protocol. So like that we focus for throughput also and the number of vehicles also increase means what is the throughput is means we our proposed protocol will provide. And packet delivery time. So suppose that which means that we are transmitting the packet from one single hop or multi-hop. So in that case also we focus for packet size and the packet delivery time. So based on we fix this so on so packet size, then what is the existing protocol to our proposed protocol? We focus for packet delivery time also. And next to packet delivery ratio. So ratio means the number of packets so successfully received or not from transmitter to our single hop communication to multi-hop communication. So what is the scenario? We are fixing so and so packet size and what is the delivery ratio. So in that case also we focus for packet delivery ratio and existing protocol to focus protocol. So this is the by using the based on that reduction techniques. So next one is suppose we are I means for example if we are going to analyze from mathematically or modeling point of view, so we use stochastic network optimization and whatever we propose multi-hop data destination protocol, so how we can improve the mobility related issues. So in that case what we did here, so queen theory models, so queen theory models we applied, and those model will give better performance to the network. So here we propose means we use the queen theory model, queen theory system MGCC, which means M is nothing but arrivals and G is nothing but general service how they are going to provide, and C is nothing but whatever the number of servers and number of users how they are utilizing the system. So we design one network. So this is also we use for Sumo, and we model this network. So and based on this model, we means in the protocol we mentioned that multi-hop data destination protocol. So once we are going to use this protocol, what is the simulation parameter we have to fix based on our twin models. So lambda k means arrivals and service. So we can fix so on so arrival time, service time, and what is the confidential interval. And suppose you are going to fix the number of servers. If you are going to increase number of vehicles, so what is the happening in that particular network? So based on that scenario, we focus for system capacity, which means the number of vehicles particular time of instant. Then what is the network traffic load in between the network? So we have, for example, lambda we fixed at a particular time of instant and service rate we fixed. So what is the case? So if you are going to fix the arrival rate is more and service rate also. So what is the increasing the system capacity? So what is the network traffic load? Obviously, network traffic load. For example, you can see that arrival rate is 0.25 and service rate also suppose 1. So the traffic network traffic load obviously will increase based on the system model. So like that we perform, and what is the waiting time? So based on they have to utilize either service or they can go for their particular destination. So how much time to wait for example, clearance of traffic. So in that case, we focus for waiting time and average throughput also. So we focus for system capacity increase means what is that average throughput based on arrival rate and service rate. And here also system capacity with respect to system utilization data. For example, in particular time of instant, how much users they utilize their data based on that we focus the system utilization. And yeah. So next one, we propose the multi-hop cooperative destination in inter-vehicle communication. So based on this one also, which means the stochastic modeling, how it is, we can predict the system performance better than. Suppose in that case also we design the system model. This is also multi-hop cooperative data destinations. So this is also we use for Sumo software and OMNet. Based on that, we propose the system model, and based on that Queen theory model, we integrate that Queen theory model. So what is the system performance? And we have to give some simulation parameters. So based on this parameter, we have to perform the system performance. Suppose if you are going to fix some arrival rate with respect to utilization, so which means that the number of queue nothing but they are waiting for some service or for example profit related service. So utilization related. So number of arrival rate. So arrival rate we are fixing. So in number of vehicles in Q5, 10, 15, 20, so on like that. So what is the utilization? So like that we have focused on by changing the arrival rate. And by changing the arrival rate, we focused on throughput also. So and we fix the number of vehicles in Q5, 10, 15, 20, so on. And we also focus on response time for users by using the arrival rate and service means and network traffic flow. So the number of vehicles in queue is increasing. What is the problem in that network? Right, that we have focused. And next one is what is meant by data traffic forwarding. So generally, we are transmitting data from source to destination, and we are trying to select the particular path. Path is nothing but the shortest path distance, multi-path. We are choosing means. So how we can overcome the means traffic congestion or collision. So based on that, there are traffic forwarding. So we propose queuing model. Based on that model, we perform the network performance. So here, this one also very challenging problem in that vehicle networks. And the next one, suppose we are, if you see this figure, this figure is nothing but multiple connectivity to vehicle or vehicle to infrastructure communication. So we use this one also Sumo and OneWay. So based on that, we what is the connectivity between vehicle to vehicle communication? What is the connectivity between infrastructure to infrastructure communication? So in that case, so you can see here, for example, in that case, what is the time instant? So our network is a random network. So stochastic network. So what is the number of particular time of instant? We are going to fix the time and one number of vehicles. So in that case, what is the vehicles arrival? What is the vehicle departure? Based on that, also we focus for performance analysis. And if you see that arrival time is we are changing from minimum to maximum, then what is the packets performance? It means packet distributions in that queue. So in that case, we already means we focus for packets in queue and what is the time to reach from one vehicle to another vehicle. So based on that, we focus this in it. And next to what is the utilization means a particular time of vehicles, how they are utilizing the data, means utilization factors, lambda by mu. So we changing the new particular time of instant. So what is the waiting time and what is the waiting time in queue? So like that we perform the analysis based on this. We can see that we can observe that waveforms shows that what is the average of vehicles in the system and what is the average number of vehicles in the queue based on the our lambda and the service time. And we also focus on this IEEE 802.11p protocol, so we can call it a dedicated short range communication. So in that case, the maximum range is 1,000 meters. And if number of vehicles is more, means we are increasing that ratio 200 once in that network and 400 or 900 above. So what is the delay between the, for example, in the transmission range? Based on that, we focus on delay also. Right. So this is the main related to vehicle or agneto. So next one is what is the stochastic traffic flow modeling, and by using the protocol name is called multi-hop cooperative destination dynamics. So here we focus on blocking the probability, how we can improve the blocking the data related and move one vehicle to another vehicle or vehicle to infrastructure communication. So this is also we designed based on our Sumo and Omnet software. And in that there is one software named Wins Omnet. If you are going to open Omnet, you can integrate the one software name is nothing but VIMs. So based on that software, we can go for different this one queuing models also. We can easily integrate those software, and we can based on the performance analysis. So you can design means you can optimize the system performance. So here we simulation parameters. So our proposed routing protocol we made multi-hop forward database is, and we mentioned that system capacity of approximately 100, and we mentioned that mean priority first come first serve, and the variance also we mentioned, and communication range also we mentioned, service time, arrival time, and whatever the speed of the vehicle and package size, data transmission rate, simulation time, everything we mentioned in that based on those software, and what is the performance between the analysis. So number of vehicles you are increasing, and what is the probability distributions, and based on simulation and analytical solutions to focus, and waiting time also we calculated based on number of vehicles is increases a particular queue. And so we focus for your server utilization. Suppose number of servers we are increasing, then what is the performance in the particular system? So like that also we focus for server utilization. Obviously, you can include Indian server is more means utilization is very less. If the server is single means if you got the number of users, our system capacity is increases means obviously that load is going to create the problem in the network. So based on that, we focus for performance analysis based on the system capacity, and blocking probability. So, for example, based on our system capacity, we focus for arrival time, service time, and covariance we in that simulation table. So we have fixed so and so times and so and so values. So based on that system capacity with respect to blocking probability and bounds of the analysis. Suppose arrival rate is increasing. So what is the service time mean, and maximum service time, minimum service time? What is the problem in that analysis? So we focus for this one also. And the next one is packet loss. Suppose we are transmitting packet from either single hop communication or multi-hop communication. So in that case, we focus for the means the system capacity is increasing. Obviously, that packet losses chances is more also. So in that case, what we did, we focus for service time, covariance time, and the arrival time. So what is the losses of the system? So like that, we focus for the changing the system capacity also. And based on that average packet delay also, suppose if you are fixing the service rate, so what is the service rate with respect to arrival rate and traffic load for unit time? So what is that packet delay? So like that we focus the particular system performance. And throughput also generally we focus based on our service time we fix it, and if we are changing the service time with respect to arrival rate. So what is the throughput performance? So like that also we focus the analysis point of view. And again, system capacity is we are going to minimum to maximum. For example, we are changing the system capacity. Here, system capacity is like the number of vehicles. So based on the vehicles in our network model or network management point of view, so we are going to fix this so and so arrival rate, service time, and coordinates time, and based on that, what is the average throughput per particular system capacity changing at random in the instant. So like that we focus, and I told you, suppose in vehicle networks. So vehicle network up to now we discussed traditional vehicle networks. So there is means dynamically changes, and how we can predict the efficient manner by using the multi-service provisioning of quality of service, but software-defined vehicle networks and software-defined vehicle networks. So, based on the software defined vehicle methods, there are several challenges we can rectify reliability and latency related issues by using the software defined vehicle methods. Suppose this one we can use, means you can see that this diagram says that upper part is control plane and this part is data plane. So control plane centralized control by the servers and switches like that. And this data plane is nothing but vehicle to vehicle is forwarding plane. So forwarding data from the you means infrastructure to vehicles or vehicle infrastructure to infrastructure. So we can use by using the data plane. So here also we can see that some simulation parameter based on our network performance. So we mentioned like that, and based on that we focus for the analysis. So what is the reliability of service? Suppose if we are increasing the arrival rate is instantly we are increasing the arrival rate and our software different vehicle networks. So and existing model. So what is the reliability? It means a particular channel. Reliable communication means once the channel is reliable, we can transmit more number of data from transmitter to receiver. So and arrival rate and with respect to our service rate also, we perform the reliability. And average response time, which means that mean time, how much they are going to wait for their service. So by using the queuing model techniques. So suppose this m by m by 1 means only one single server. If we small m says multiple servers. If once you are improving means taking multiple servers means obviously our system performance or load also we can reduce particular time of install. And based on that, we have focused the service rate also. We once we are increasing service rate, obviously that response time also decreases based on these three models. And resource consumption. Suppose how much users they are consuming the resources particular time of instance. So on existing model and proposed model is provide better resource consumption when compared to the existing model. And resource utilization also. Suppose we can improve you can instantly changing the service rate. So what is the utilization of means each user utilize the resource allocation with particular time of instance. So based on that, our proposed model, we provide better resource utilization to the number of users. And delay also we reduce based on our proposed model, and we have on our proposed software development networks proof it also will improve based on particular time of instance. And for example, the software defined heterogeneous vehicle networks. So heterogeneous, I told you. So we can integrate more number of enabling techniques, and based on that techniques, we can perform well for compared to the software defined vehicle networks. And here the major issue is load and scheduling related how we can schedule the particular time and the network for first comes or which kind of schedule we can follow to resolve the challenges in particular networks. So based on that, we model by using this means arrival and service by using different mobile means base station and controller, STM controller and servers if we are going to improve on server environment. So general case, we can improve general service, general arrival and single server, then what happen in the network. And based on that simulation parameters, so we mentioned that same 1,000 meters for that radius means transmission range and number of vehicles we fix minimum to maximum, and which means that enhancing, enabling, taking means that deadline. So based on that, we focus for so and so time minimum to maximum time, and number of arrivals we fixed minimum to maximum. And the simulation runtime we fixed 3.67 minutes to 5 minutes. And based on that speed of the vehicles we mentioned, and based on that we mentioned the transmission rate also. In the based on that analysis, we perform the waiting time, the traffic intensity is increasing. Then what is the analytically and simulation for GG1? G means arrival for general service generally, and G means service for general. You can take any distribution and exponential distribution we can consider, and only single server, then what happened in the particular networks. And what about the average waiting time? And in case of saying here GG1 and GM1. G means general and M means in Markov model, exponentially service here service is exponential. So based on that, we calculate the minimum to maximum of our traffic intensity, we focus for average waiting time also. And based on that, we focus for throughput also. And throughput means each vehicle to infrastructure, vehicle to vehicle communication, internet, and the number of servers, minimum to maximum. Then what is the link incoming and outgoing? Based on that case, we calculate the throughput also. Based on arrival rate, minimum to maximum, and arrival rate minimum to maximum, again we focus the response time and utilization also. And generally, that is arrival rate. And then next we focus for the service time with respect to our throughput and response time and utilization. And based on that criteria, so which one is better means response time, and which one is better throughput based on this condition, and which one is better means utilization percentage is better based on this condition. And we focus for enhance means there are several scheduling techniques. Based on those scheduling techniques, so we what is our network utility, particular time of installment, how much users they utilize the network based on our enhancing arrival rate, and with respect to our network means these all are scheduling based on the what is the condition for network utility generation. So we focus for in this scenario also, and we focus for the arrival rate, and again we focus for scheduling with respect to our software defined heterogeneous virtual networks. So always our proposed model is better as compared to the scheduling, and we focus for the same again arrival rate. We got the vehicles in queue. Suppose 4 vehicles, 8 vehicles, 16 fuel like that. So what is the scenario? We are improving the means increasing the arrival rate. So what is the utilization in that particular network? So based on that, we focus. And what is the conclusion means? Suppose I told you we focus on mobility prediction based by using different routing protocol. So we avoid collision related issues, and we can usually control by using the routing protocol. By using the stochastic processor being modeling for data forwarding from vehicle to vehicle or vehicle to infrastructure. So we can improve the connectivity also. And based on the 4G technology, 5G, 6G, we can improve the point-to-point, point-to-multi-point communication between the infrastructure to vehicle or vehicle to infrastructure communications. And we can optimize the queue length, waiting time, and delay in the integrated communication system. And reliability also one of the means QoS parameter. So based on this reliability, we can enhance by using the software different networks and different scheduling techniques. So which depend on our arrival rate, service rate. So we can achieve the network utility imagination by using the software different networks. And what are the future directions? Suppose you can see that integration with emerging technologies, either we can At present scenario, you can apply AI, ML, and different this technology. We can use routing performance and resource management efficiently for the particular networking scenario. And digital twin models also nowadays very famous topic. So we can integrate this digital twin models into the vehicle communication. And real time we can do simulation also by using this technology. And blockchain for secure and decentralized vehicle to anything communication. And ultra reliable low latency communication, one of the major topic in data communication. So this topic, based on this, we can integrate 6G technology or any AI ML models, and we can optimize the latency, and we can means latency and safety related applications. And edge and fog computing for faster decision making by using the 6G and advanced enabling technology and spectrum network management. So in that case, what happened means, suppose if you are going to decide some spectrum bandwidth. So and how we can efficient communication we can provide for user to user, vehicle to vehicle or vehicle to infrastructure based on. So these technologies also we can use in cognitive radios and software defined vehicle interface for flexible control and programmable easily compared to the means WAN. And multi-access edge computing for seamless handovers also this is also very challenging topic in spectrum and in the network manipulated. And 5G and beyond 6G and vehicle to anything. So terahertz millimeter wave communication for ultra high data rates and AI for 6G by using. So we can improve the different QoS parameters. So these all are future direction. So these all are references and thank you. And if you have any doubts, you can carry on. We can discuss doubts later. Yes, sir. Can you hear me?
Yes, Dr. Ravi, I can hear you.
Yes, sir. Yeah. Is there any doubts?
Is there any doubts, audiences? Can you, sir, you are free to ask Ravi any questions regarding this next generation vehicle. You are free to ask. Anybody, anything else? Okay, Dr. Ravi, I have
Yes, sir.
one question. Can you
Yes, sir.
about the data rate in next generation vehicle?
Sorry.
The data rate, about the data rate.
Data rate.
Can you little elaborate about software defined vehicular network at the starting? Heterogeneous vehicular network, software defined.
Yes. Yes. Yes.
Can you little bit explain more?
Yeah, actually, normally in vehicular networks, there is the IEEE standard 802.11p. So we can give nominal data rate minimum 3 to 27 megabits per second. Right. So based on that data rate, we can focus for throughput and what it means related to due to the we can call it as interference, any link failure, and we can control the mobility usually by using the data rate. And you can use for related normally whatever safety related issues. And I told you some cooperative awareness and we can use for routing protocol based on the nominal data rates. Are you getting my point?
Yes.
So normally in SDN or normally we can minimum we can go for 3 to 27 megabits per second.
3 to 28 megabit
27 megabits per second.
Thank you, sir.
Yes, sir.
Is there anybody any questions or any doubt? Feel free to ask, sir. He has any more?
Yes. Is there any queries?
Please go on. Participant, please go on if you have any queries. I think nobody has any question.
Okay, thank you once again for giving me this wonderful opportunity to
Enlightening
inviting this FDP session. So thank you once again, Pradip Naiki sir. And thank you whoever participated in this FDP program. Thank you so much.
another
Have a
thing,
nice day.
one thing.
Yes, sir.
Actually, we have a small amendment for you.
Yes, sir.
Please accept it. This is
Sir, thank you so much.
is visible, sir. This is
Yes, sir. Yes, sir. Yes, sir. Yes.
kindly accepted.
Yes, sir. Thank you so much, sir.
Thank you, Dr. Ravi, for your informative session. And anybody have any questions? Or you can free to ask. I think nobody has any question.
Well, sir. Shall I wonder?
So, sir, I think I close this lesson 5.
So thank you, sir. Have a nice day. Thank you so much. Good evening.
Good evening, sir. So,
Yes, sir.
little bit break, and then we have a new speaker, Mr. Ranojoy Ghosh, will connected for 20 minutes later. Let's give some break. Then we'll start the session from 7:30.
Thank you, sir.
Okay, sir. Thank you, sir. Thank you for your
Okay, sir. Right.
informative.
Right, sir.
Please wait for a few time. Let's take a break, and Dr. Mr. Ranojoy Ghosh and you. He's a program and project management director of LTI Pointry, Kolkata. He will take the session on AI in communication. Keep listening. Then will be more interesting.